Welcome to Cornerstone Home Inspection Inspector Education Center. Tonight we have Conditioned Attic Space with Stan Badursky. I will hand it over to Stan.
Good evening, everybody. Thanks for attending. Today we're going to talk about a topic that I'm going to go out on a limb and say that most home inspectors aren't seeing a whole lot of. At least in my I'm in my 36th year. I think I've seen about 12 conditioned attic spaces. I'm going to say that I don't keep records, but probably half or a little more were new construction, and then the rest were retrofits. So we're going to talk about the science behind the conditioned spaces, definition of conditioned space. We'll talk about unconditioned vented attics, which we see the most of, unconditioned unvented attics, conditioned unvented attics, insulated roofs, the pros and cons of all of that, air handlers in attic spaces, and combustible furnaces in unvented attics. Okay, Jim. So the definition of a conditioned space: any area inside a building envelope where temperature and humidity are controlled is called a conditioned space. This includes the active and living spaces found in both residential and commercial buildings. Alternatively, an unconditioned space is any space inside a building envelope with no means of regulating temperature or humidity. Areas like garages, attics, or crawl spaces. In this case, the interior space conditions approach those of the outdoors. Okay, Jim. So as we were talking before we came online here, there's been a lot of chatter in our profession about conditioned attic spaces recently. Most home inspectors, as I said, do not see them often. And when they come across one, a lot of times they're not sure what they're looking at. So while putting this presentation together, I could not find a definitive time frame as to when conditioned attic spaces became a thing. However, articles discussing the topic date back to 2000. Scott, were you here?
Yep.
Do you remember when Larry brought us down there for a couple months in a row and talked about his version of conditioned attics? That had to be before 2010, right?
Yes.
That was a while ago.
Probably around 08.
Yeah, that's what I thought. So I know from Scott, from past experience and past seminars that we attended, that it evolved from being applied during new construction to being sold as a retrofit for older homes with vented attics. In Connecticut, there is a well-known basement waterproofing contractor who is franchised internationally, and for tonight's purposes, we'll call him LJ. LJ got into the energy field, first partnering with a local HVAC contractor, doing energy audits, and then breaking with that contractor and pushing his own brand on the energy field. He has about 8 buildings in his complex, one with the hands-on training facility and classroom that he let us use or invited us in to sell his wares, basically. And through the Connecticut Association of Home Inspectors, Connecticut home inspectors learned a lot, or those who attended those seminars. I think it was like 3 or 4 months in a row at his facilities. So still, you have to collect and sift through the information each time you come across a conditioned space. All right, Jim. So coming from the trades, I was knowledgeable when I started my home inspection business. I can remember back when I first started out running across something I was not familiar with, and we all did. However, the new guys and gals today may look like this when they walk into a conditioned attic, that deer in the headlights syndrome. So a vented attic is a type of attic space in a building that has working vents. In theory, I put that in capital letters because theory doesn't always turn out to practice properly. These vents allow for airflow, which serves several purposes. Temperature regulation. In cold climates, vented attics help maintain a cold roof temperature to control the formation of ice dams caused by melting snow. By allowing air to circulate, they prevent excessive heat buildup in the attic. 2, moisture control. Vented attics also help ventilate moisture that may move from the conditioned living space into the attic. Proper ventilation ensures that any accumulated moisture can escape, reducing the risk of mold, rot, and other issues. And number 3, detecting and solving leaks. So when a leak occurs in a vented attic, the exposed and ventilated rafters and decking make it easier to detect and address roof leaks or other moisture-related problems. The drying process is more efficient due to the airflow. So here, the norm and still out there is an unconditioned vented attic space. So you will have the ventilation, whether it's that gable vent or ridge and soffit, insulation on the floor. I don't mean the wood floor, the subflooring there, but it's in the rafter bays or joist bays. And then theoretically, air is going to flow through there and cooler air and cool the roof and get rid of moisture that may accumulate in the attic. And they're all perfect when you get up there, right? All that ventilation works 100%. Okay, Jim. The physics of vented attics. Any opening on the ceiling between the conditioned space of the house and the vented attic is a leakage point for heat and moisture to pass from the conditioned space to the attic. That is why it was always a recommendation to air seal as much as you could during construction or renovations. In theory, proper attic ventilation would lower the attic temperature and remove excessive moisture. Insulation would help energy efficiency. So we all know now that, I don't know what percentage, but it's pretty high when we do the older homes. To me, probably 2 of the last components that get updated in the house are the windows and the insulation. So I think we typically find that most of the older homes, probably maybe even pre-80s, are under insulated unless somebody got in there and did their thing. And they all have this type of ventilation and probably not enough, as we'll see coming up. Okay, Jim. Jim?
Think he froze.
Jim.
He froze. He froze, Stan.
Oh, he's frozen.
Hold on.
There
Yeah.
he is.
Give me 1 second.
Take 2.
All right. I don't know what's going on here. Okay, we're back.
So when we were at one of the seminars with LJ, he kind of told us that if air, so the typical insulation in an attic is some bat or blanket fiberglass insulation in the joist bay. All right, so those are 2 floor joists on the side. I drew this picture, by the way. If you can see the orange, that's supposed to be insulation. There's the vapor barrier on the bottom, the sheetrock ceiling, and the living space below. So LJ says if air gets in between those corners that don't fill in properly, or between that bat and the ceiling, or up between the bat or the insulation and the attic joist, that completely eliminates the effectiveness of the insulation, and that it is totally useless. That was his theory or his teaching. All right, Tim. For me, something is better than nothing. That insulation's got to be doing something. I'm not going to say it's perfect, but it's got to be slowing down heat loss, stopping some of the moisture that may be coming up there. So I disagree with him on that point. So anybody that views this after as a pre-recorded webinar will need to put this view code CS080456, report it to us to get credit. There'll be one more coming up. So air sealing is always recommended. Any penetration in the sheetrock can be sealed very easily, but access to a lot of those things probably not that easy in all areas. And it will cut down or stop, depending on how well you do it, heat loss passing through into the attic and moisture. Don't forget, when we are cooking, breathing, and bathing in a home, we create a lot of moisture. That moisture's got to go somewhere, especially in the winter when we got windows closed. So it's going to try and migrate up into the attic. Okay, Jim. This formula probably everybody has read before, and I'm not going to go through it word for word, but this tells you how to calculate the minimal size requirements for attic ventilation. And so there's ratios and the formula, and it's based on the square footage of the attic space, and it'll come up with free vent space. So free vent space has to be increased if you have a screen or louvers, because that'll slow down the air movement. Okay, Jim. In this picture, if everything is perfect, then the cooler air comes in through the soffit vents, and the stack effect of the home actually helps draw it up through the ridge vents and expels it at the higher vented portion of the roof. Now, that's provided that there's nothing else going on inside that attic that can interrupt that flow. And it should stay close to the roof and wash the roof and cool it down. That's the theory. The two things I've learned over 54 years I've been in the trades: theory does not always translate to application, and the experts do not always hold to their theory. The other thing that is important in this application is that the insulation on the ceiling there has to have space to allow that air to come in from the soffits. And I think that we all have seen our share of that insulation piled right up against the sheathing of the roof. So the only thing that's working on that house would be the ridge vent, and probably not very well.
Stan, while you're with this picture, can you just talk a little bit about, like, we see it all the time where roofers will come in, they'll put the ridge vent in, there may or may not be soffits. There may be soffits when you see outside because they side it, but they didn't open up the original soffits
Right.
that were closed off, and the gable vents are open. What could you just maybe touch a little bit on issues that we see, the problems that could be with that?
Sure. First of all, I should have mentioned while we were first talking about this picture that theoretically your free vent space should be divided by 2. 50% of that should go in the ridge. Then the other 50% should be divided by 2, and 25% put in the front, and 25% put in the back. Now, I don't care what profession you are talking about, ours as well. There's discussions about you can't overventilate an attic, because I think most of us, again, will agree that when we see a ridge vent, it's probably over 80 to 90% of that ridge. All right, when we see soffit vents, from visual, it's the whole soffit, front and back. I don't pull material down to see if it's open all that way behind it, but it's installed, at least the vinyl or aluminum material is installed 100% all the way across. But if you're set up right and you have that gable vent still in place, that could short circuit that flow that's supposed to run up against that roof surface there and prevent the attic from venting properly. But we're going to get to a couple pictures where I think that we will all agree, again, because we see this, we go in all these attics, that there's houses that don't look like there's enough ventilation, but the attics, I'm not going to say temperature wise all the time, but they're clean. There's no mold, there's no dusting. Then we go into attics that look like they're improperly vented or well vented and have mold and things that we believe are issues related to ventilation. So there's no rhyme or reason. You have to get in that attic, no matter what you see outside, to see exactly what's going on. So Scott was perfect in pointing out that combination of all that, and then you may see turbines or actual roof vents or an attic fan. You know, it's hard to determine if they're all going to work properly or not, especially if you go in and the attic's clean. Now, here are three pictures of attic spaces that had ventilation, and these are the higher end of the spectrum with mold problems, but there was no airflow. If you look, it's pretty clear on the picture on the right that the insulation in the floor is just going right up against the roof sheathing and cutting off the airflow from the soffit vents. Now, the source of the moisture, who knows? Could be wet basement, wet crawl space. There could be openings from. I did a house once where the attic pull down was in the bathroom and it didn't close. So every time those people took a shower, all that hot, moist air going right up to the attic. And in the wintertime, when the roof is cold, it looked like this. Only, though, in the two bays over the pull down stairway and one bay on either side. The rest of the attic was clean as a whistle. So that's why you got to get up there and see what's going on. I think that was an easy fix. I don't think they were going to move that pull down, but they certainly had to seal it somehow and get it to close properly. So we've all seen this, and this is not good, obviously, but this is with ventilation. This is a vented attic. All right, Tim. This is a 2019 home that was new construction. It had ridge and soffit venting when I inspected it, and it was for this young gal who was a paralegal, and she knew everything. I forgot. I think we were doing a 1-year anniversary because she was living in there already. So the ridge and soffit vents were open. Temperature outside was 45 degrees on March 3rd, and attic's temperature was a balmy 75. So I find this discrepancy often in homes with this voluminous attic spaces. My theory, just a theory, is that there's too much heat sink in that lumber and too much distance from the soffit to the ridge for that all to work properly. Just a thought. I don't know how to prove it. But there was, that's 30 degrees difference from outside to inside air.
What do you stand for the I usually use 10 to 15 degrees, but what do you do for if it's 45 out, you don't want to be higher than 55, 60 in the attic?
Well, it should be colder if you're getting enough air in there.
Yeah, it's not going to be the same. It's not going to be the same as the outside because it's an envelope.
The statement says 10 to 15 degrees. Even if it's not, no matter what time of year, it's improper ventilation.
All right.
I know it's kind of hard to believe, but so the physics of the unvented attic, conditioned attic space part of the house, it's heated and cooled, and is often referred to as an unvented attic. In an unvented attic, the insulation is at the roof deck instead of at the attic floor, making the attic part of the conditioned space of the home. This protects heating and cooling equipment and ductwork located in the attic from temperature extremes, so it will last longer and operate more efficiently. The attic space becomes indirectly conditioned as a result of air leakage, heat transfer, and vapor diffusion through the ceiling. There are unconditioned unvented attics, conditioned unvented attics. Okay, Jim. In an unconditioned unvented attic, they're constructed with the thermal insulation at the ceiling line. Did I put the wrong picture here? Oh, ceiling line, right. And the attic space is not thermally connected to the building. That vapor diffusion part up there, we're going to talk a little bit more about that. That often looks like a ridge vent. And you may think, oh, this house is vented, but it's really not. Next slide.
Stan, I just wanted, there's somebody just I'm gonna say it's Gary. I'm assuming it's Gary. It says when you change the color, the roof temperature changes. Something to consider too. Dark roof. I mean, I'm
Oh
assuming
yeah, absolutely,
darker roof,
absolutely.
ones that are in the middle, and definitely, different climates, different roof colors. So that's
So
definitely.
this, a couple slides back, I said that theory doesn't always translate to application, and that there's things that can affect all of this inside and out. And these are the types of things: tree lines. How many times have you seen a half an attic all moldy and the other half not? And you go outside and there's a big tree line on one side of the house. So it's not one size fits all here, and you got to use your head when you're looking at this stuff if you're going to make a recommendation on how to handle it. So
Plus,
so
people jam a lot of storage in attics a lot of times, and that will prevent airflow.
that's another thing. And same thing, but that also needs to be recorded because it stopped you from really getting in there and seeing what you should have seen anyways.
100%.
So, so the vapor diffusion port, it's a component used in roofing systems to manage moisture. Here are some key points about vapor diffusion ports. It is typically located at the ridge of a gable roof or at the hips of the hipped roof. The ports allow moisture in the attic to be removed by diffusion rather than by air change. It prevents air from moving into or out of the attic while allowing water vapor to escape. So it does maintain, if installed properly, a sealed attic. And the port is covered with an airtight, watertight, but vapor open layer. So the next picture will give you an idea of what it looks like. So it's a little, I'm going to be honest with you, I don't think I've ever seen one. In those houses that I've done that had unvented attics, I don't remember seeing anything like this. So it looks like an oversized, overgrown ridge vent. And I think that's part of the reason why, if they weren't being installed, that you're not seeing more of the foam anyways, I think, and we're going to talk about that a little bit more into this presentation. So the conditioned unvented attics are constructed with thermal insulation at the roof deck, and the attic space is thermally connected to the building. So they usually have some way of allowing some of that air, at least in new construction, to get in the attic. The couple of houses that I did that were new construction were actually using a air-to-air heat exchanger, and they were actually tying in the bathroom exhaust to that as well. But when you get in those attics, you can actually feel the difference when you're up there, and even the sound, because that insulation's up on the roof. Okay, Jim. So the types of insulation that are used, so the foam is what I was seeing for a while in those new constructions. I remember the first time I did one, my first thought was, Jesus, especially in the basement. Like, I can't see termites. I can't, how do you get wires through this shit? How do you get piping through here? What if the roof leaks? You're never going to know. And those have all become concerns after the fact, after we started pushing the foam. But the foam is supposed to cover the rafters, and I'll tell you why in a minute. If you look in the middle picture, that's rigid foam boards. That's what LJ was. He actually patented his own, and what he told us was his boards are going to go across all of the rafters, and there's going to be, I think this was his version of the air diffuser, ventilation behind there to cool the roof as well. And then there's rock wool in the right picture, but the joist rafters are exposed, and those create a thermal break, and that's why LJ wanted to put his boards across those rafters to encapsulate everything and try and get them all to be the same temperature.
If if you sheetrock that over the rock wool, though, doesn't that? It's
It's not
still a thermal
insulated
break.
though.
It's still a
not-
thermal break.
It's still a thermal break, yes.
Okay. All right.
So the key to the unvented attic and roof assemblies is to control condensation or moisture accumulation on the underside of the roof sheathing. This can be done in several ways. One way is to raise the temperature of the roof sheathing by insulating on top of the roof sheathing. Insulation added on top of the roof deck can be vapor impermeable or vapor permeable. All of the rigid insulation board products work, including mineral wool and rigid fiberglass. There must be an air control layer or air barrier under the rigid insulation boards. The air control layer can be a fully adhered membrane on the roof deck, or an air control layer can be the roof deck itself, airtight sheathing with white taped or sealed seams. The rigid board insulation should be installed in multiple layers with joints offset to limit three-dimensional airflow networks within the multiple layers of this assembly. I can say I've never seen that. Has anybody seen or inspected a house with insulation on the roof sheathing
No.
outside? I gotta guess you're gonna see it because it's thicker. It's a thicker roof. There's another layer of plywood on top of that, and then a membrane, and then the shingles. But I don't think I've ever seen it. I gotta think it's gonna stick out like a sore thumb. That we're gonna go, what the heck? But I've never seen one, so I couldn't tell you.
We have a question.
Yep.
Maybe we can comment on fiberglass bats installed between rafters.
I think you touched on that in the beginning, Stan.
Oh, okay.
No,
Yeah. And the rafters.
Yeah.
A lot of the
Sorry, you talked about
a lot of the older houses, they applied the insulation in the attic, and you know, that's, well, just from an effective point of view, the insulation should go against the space you're heating and cooling, right, against the conditioned space. So the attic is not conditioned, it's ventilated, and you put the insulation on the roof, that's not going to help your living space at all.
No.
Plus, I think it's detrimental to the roof's life.
So
those
I
were
can
just not good practices.
jump in with a short story. As I just did an inspection in Bristol on a house that didn't get permits. The building inspector made them go up there and rip the sheetrock out of the attic space, leaving the bat insulation in between the rafters. So at that point, the proper call is, you know, if it's not finished space, that has to come off the roof because it's not proper installation. But if you get permit and re-sheetrock it, then it is, because it's
correct.
Right. So
And
there's
the only thing to add, I'm going to use my attic because my attic's finished. 1920 walk-up colonials. When I installed the fiberglass bats between there, I used the vents, the proper vents. You know, those foam vents.
the bats.
No, it's actually foam vents that allow the air to flow from the soffit all the way up to the ridge vent. In other words,
Oh, the chutes.
insulation. Yeah, you know, the little baffles. Those baffles that we see when we do an inspection, you'll see the baffles in the soffit. When you walk up in an attic, you see insulation, like Stan had that picture where it's jammed all the way up to the soffit. Well, a lot of times, if it's done right, unfinished attic, you'll see that those baffles will be shoved down in there, and it goes down into the soffit. In that case, like mine, you know, I have sheetrock, and there's nothing in the floor. Well, it might be some of the old stuff from the 20s, very, you know, the old rock wool, but not much. And then I got those vents, and that's okay, and that was acceptable. You know, could I have spray foamed it today? I'm not a big fan of spray foam for my own personal reasons, but you can do that. If it's, you know, if you just push it up in there, you're not going to get the ventilation. If it's just right up against the roof sheathing,
Right,
it's not going to ventilate well, and it defeats the whole purpose. So yeah, you got to get it out of there. But other than that, if it's done right, it's not a big deal.
and you know, the foam, if it's not applied properly, will separate from the. I've seen a couple houses here in my hometown, same builder, that there was a couple. The third floor, well, they called it a third floor. It was the attic that was finished, and there were a couple spots that weren't, where you can actually see the insulated areas, and it was separating. And you know, we were only able to see small portions of this, and I'm going to say 85% was covered with sheetrock for living space. So that was a big issue. That probably is another reason why the foam kind of, I think, at least in this part of the country, kind of died away. Not the theory so much, but the foam.
I mean, I don't know what they do if you foam this thing, 20 years goes by, you got to put a new roof on, and there's been water intrusion. Now the decking needs to be replaced. How do you have to just saws all that out with the foam insulation?
It gets ripped right out with all that foam. And then here's the problem. You think the roofer is going to put it back? No. And we're going to see a lot of problems, maybe not in our time just yet, but some of the, the newer guys in the business are going to see a lot of problems. And then it leaks over there and you don't know where the leak is. It's going to be a problem. And
I'm sorry, Scott, go ahead.
No. And I'm seeing now, I just going back to when you start popping through, guys will come at bathroom exhaust fans. They'll do stove vents. They cut all that stuff out, radon systems. And guess who foams it back up? Nobody. So, it's going to be a problem. I mean, my father-in-law, rest his soul, he always used to say, I like a leaky house. We all talk about the houses are so tight now. We're creating problems within, and that's why they have those air exchangers and the fans that are constantly going on. Because if you really think about some of these older houses we inspect, Stan, how many older houses you go into? They're not well insulated. They're just maybe the 2 gable vents, maybe a couple windows, no mold, no issues up in the attic.
Right.
They might be leaky. They might be colder. The house is colder, plaster, but yet you're not seeing the problems. And I think we've created a lot of problems. Some of them have been fixed, but I think, like to Jim's point, we're going to have a problem in the future with that foam. That's why I'm not a big fan of it, but it has its purpose.
So this is by no means a political statement, so don't take it that way. I'm all about trying to be energy efficient, but you want to be practical about it. And to throw some, I'm going to say shit out there that in theory works, but hasn't really been tested. It's like anything else that we use in the trades, right? So copper's tried and true, but all of a sudden copper becomes expensive. So now we're going to use plastic pipe. Almost every form of plastic pipe has its issues, right? But it's going to stay. You're just going to have to deal with it. So now we're starting to see the problems with this material, and hopefully it becomes a thing of the past and we figure out another way to save energy. You got to think it out a little farther than, oh yeah, let's do it. It's got to be thought out, because people are going to pay the price someday for this if it goes the direction it was going. So back to the presentation. So it's not necessary to install all the insulation on top of the roof sheathing to elevate its temperature sufficiently to control the condensation and moisture accumulation. Some insulation can be located above the top of the roof sheathing, and some of the insulation can be located on the underside of the roof sheathing. Sufficient insulation should be located above the roof sheathing to keep the moisture content of the sheathing below 20% by weight for the coldest part of the roof. Roof sheathing moisture content drops quite quickly in the spring. The roof sheathing moisture content should be below 16% for the summer and the fall. These moisture content limits have been shown to also address mold growth based on historical experience. How much insulation should be located above the roof sheathing depends on the climate zone and the interior moisture load. So if you determine that you have an insulated roof similar to one of these two, at least you have a little bit of knowledge about how they may have been constructed. But me, if I see that, if I have an inkling or I know that these are insulated roofs, I'm not going to take responsibility for them being insulated or installed properly. I'll figure out how to address that in my report when the time comes. But so pros to unvented attic spaces. So conditioned unvented attic spaces have significant advantages to unconditioned vented attics. The building enclosure can be made significantly more airtight, much easier by constructing an unvented attic, thereby making the building much more energy efficient. Ductwork and air handlers typically leak, leading to significant negative pressures in the building when they are located in vented attics. By installing insulation on the underside of the attic roof sheathing, any ductwork or mechanical system installed in the attic are now located inside rather than outside, again, making the building much more energy efficient. Ductwork and air handlers typically leak air, which leads to significant negative pressures in buildings when they are located in vented attics, with resulting energy penalties. Unvented attics are also significantly more fire safe in wildfire areas and where neighboring buildings are close. Ash and embers enter typically attics through the attic vents. No vents means no ashes or embers entering attics, and much less risk of fire. In high wind regions, particularly in coastal areas, wind-driven rain is a problem with vented roof assemblies. Additionally, during high wind events, vented soffit collapse leads to building pressurization and window blowouts and roof loss due to increased uplift. Unvented roofs, principally due to the robustness of their soffit construction, outperform vented roofs during hurricanes. They are safer. Those are just regular hurricanes. The monsters that have been coming around lately probably blow the whole house down. In coastal areas, salt spray and corrosion are a major concern with steel frames, metal roof trusses, and truss plate connectors in vented attics. This is not an issue in unvented attics. So I'm going to say that as long as it's not foam, then there's some pluses to the unvented attic. Next
So
slide,
Stan,
Joe.
let me ask a question. Since we're talking about air handlers, so what do you call out when you go into a ranch style house with an unfinished attic? Maybe it's got a ridge vent, two gable vents. There's no basement. It's 1,000 square feet, and they put the gas furnace in the attic, and they're venting that directly out of the roof line. So that system now is considered into outside space. Are you calling that out as an improper location for that?
We're going to get to that.
Okay.
Can you wait till that slide?
Yeah.
Okay.
It's no emergency.
So the cons to unvented attic space. Roofing panels can get wet when designer construction flaws allow moisture in. And as home inspectors, we know that all trades have construction flaws. All right. There's the good, the bad, and the ugly in every trade. There's guys that do a really good job. And there's guys that aren't doing a good job. And we find that. So, so those flaws allow moisture in when ice dams damage shingles or when strong winds and storms damage the roofing. Wet roofing panels have even less of a chance of drying in an unventilated attic when insulation has been applied directly to the underside of the roofing panels. This problem is substantially exacerbated when there is an impermeable layer on top of the roof sheathing, or example, some adhesive underlayments for shingles. Spray foam insulation is more expensive than batt insulation and needs to be expertly installed to prevent missed areas or pockets that can reduce the efficacy of the building envelope. Poor workmanship during attic and roof installation will result in expensive callbacks and repairs, as insulation will have to be replaced. A study done recently in South Carolina showed that open cell foam can accumulate moisture that could potentially cause structural issues for roof sheathing. The researchers speculated that exterior moisture, dew or rain, between the roof shingles is forced into the roof sheathing by inward solar vapor drive. Another study's computer model indicated that open cell foam insulation is riskier than closed cell in all U.S. climate zones. An alternate to spray foam insulation in an unvented attic is plenum trusses, which allow you to create a reverse bulkhead above the ceiling plane that is insulated. This allows you to install your bulkheads above the ceiling plane without the need to spray foam insulation. The trusses do cost more, but this added expense can be mitigated by a reduction of the size of the HVAC system, thanks to ductworks being inside a conditioned space. I don't see too many builders spending money on that, that's for sure. Over the lifetime of every roof, there is bound to be a little moisture that creeps in. Improper installation of roofing materials and flashing may allow some moisture to enter, or poor maintenance, deterioration of roofing materials, or storms all contribute to increase the moisture content of roof sheathing panels. In an unvented attic, this moisture must have a way to get dried up, or panel issues may result. So it's not a flawless system by any means. Everybody's got to be on the top of their game when these things are being installed. So homeowners insurance, I have heard, but when I researched it, I think the next slide will tell you what I found. I have heard rumors, but have not been able to confirm during my research, that insurance companies are starting to balk at insuring homes with foam unvented conditioned attic spaces. So that'll be interesting to see how that plays out. So the National Roofing Contractors Association. While the National Roofing Contractors Association considers unventilated attics a viable alternative, they do warn that some shingle manufacturers' warranties may be rendered void by unventilated attics. Steep slope roof systems, performance problems caused by condensation and heat, history unmitigated by ventilation, are cited by some asphalt shingle manufacturers as grounds for their limiting or entirely disclaiming liability under product warranties for asphalt shingles installed over unvented attics. Homeowners considering asphalt shingle installation over unvented attics should consult asphalt shingle manufacturers to verify warranty coverage. Who's going to tell them that? Us? I mean, we tell them about everything else, so I don't think the roofer's going to, but we'll see.
I think I remember something to the fact that if you do put, if a roof's installed like that, you know, it affects the life cycle, maybe 5-6 years at the back end of it.
But we can tell, you know, we can tell people something at the inspection. I think, first of all, most of us on this side of the country have our buyers with us. Actually, I'm at a point where I don't even want to do an inspection if they're not going to be there, unless they're in another country or on the other side of it. If they're just not coming because they got to go to work, that's a problem for me. But you can tell them things that they won't even know 2 days later. Some people probably wouldn't even know, even if you told them that they have an unvented attic. So even if they heard that, it may not ring a bell. Okay, Jim.
Oh, here we go.
So a furnace in an unvented conditioned attic. When both constructing conditioned unvented attics and unconditioned unvented attics, and retrofitting attics to become conditioned unvented attics and unconditioned unvented attics, it is critical that only sealed combustion appliances such as gas furnaces and gas water heaters are installed in such unvented attics. The atmospheric combustion, Jim, can be installed in a vented attic.
Or it can't be. It's got to be sealed. Oh, it can be. Okay.
In an unvented, in a vented attic.
Because you need
So
to
if it's vented,
air.
It can't be in a sealed attic or a unconditioned, unvented attic.
Okay.
Right. So you can put a high efficiency condensing style furnace or water heater up there because it's bringing its own air in from outside. But that atmospheric combustion, if you got a tight attic, it may not be getting enough air, and it's going to create more carbon monoxide.
Okay. So that's a no on the left, a yes on the right. Okay.
Correct.
Yeah, because it's bringing in its own air. Okay.
Where you might have a problem too, Jim, that you can make some of the older units, you know, some of the ductwork is not insulated, or it's torn, or it's fallen off. So sometimes you'll see the water stains or mark, or you're like, where's those stains coming from? You know, a lot of condensation, especially with AC, and even it could be with heat too, but more so with AC, I see a lot.
So note that unvented attics do not always have to be conditioned. I don't think I've seen one where they, or at least I didn't see that they were bringing conditioned air from the living space up into the attic. Might have been there and I didn't see it. The ones I'm afraid of are the retrofits. All right. So somebody's they want to put air conditioning in their heat only house. They put the air conditioning, the air handler upstairs. They're dropping the AC down from the ceiling, and they get the bright idea before they do that to seal the attic. You could bring anybody in to put the foam in. Doesn't mean that they're gonna, put the vapor diffusion port or. So especially in retrofits, you really need to look around for that, because eventually there's going to be moisture buildup up there. Not from well, who knows from where, but from the house, unless they sealed all of those openings to minimize it. So just to read through this occurs when the attic is unvented and the insulation is at the ceiling. They are not part of the house that is heated and cooled. The model codes allow both conditioned and unconditioned attics. More specifically, the model codes allow conditioned unvented attics with fiberglass and mineral wool, and unconditioned unvented attics with fiberglass and mineral wool. Right. So both have the diffusion port. Okay, Jim. So attic air handlers and attic spaces, we kind of touched base upon this a little bit, but in a vented attic, and we see them a lot, right? The air handlers up in the attic. It's 105 outside. It's probably 90 in the attic. We're trying to run cool air into the house, but we're running it through this air handler. It's getting baked. So we may cool the house, but we're not going to cool it efficiently. It's just not going to be anywhere as near efficient as it should be. But that's just the way we're finding them in these older homes. You put that air handler in an unvented attic, it's going to run as efficiently as it can run. So the conditioned unvented attics have significant advantages over vented attic, unconditioned vented attics. The building enclosure can be made significantly more airtight, much easier by constructing the unvented attic, thereby making the building more energy efficient. We kind of went through this already with the leaks and stuff like that. So sealed attics are unvented attics. If you hear somebody talking about a sealed attic, it's basically an unvented attic. They are the living space below and any ductwork within needs to be sealed and insulated from the attic space. For an unvented attic, the whole attic is an extension of your home and therefore must be sealed and insulated. Building code requires attics to be vented unless they are sealed and conditioned. There was no question about that up until whenever this unvented stuff started happening.
So building code requires attics to be ventilated, unless they are sealed and conditioned. Okay.
Well,
so if they're sealed and not conditioned, you see that a lot on like old 3 families where you got that attic space, and then they just put insulation into the sheetrock it, and then they're done because the heat from the first and second floors is heating the attic.
So many years ago, I did a ranch here in Milford. And when I was doing the outside, I noticed the gable vents were completely sealed off. So I do outside first. I go in the basement. There was this partial basement for the mechanical systems, and then a very, very, very wet crawl space. It had gravel, but it was like a wet, pool with gravel placed in the water. And when I got in the attic, first of all, I asked these people, they were renting and they were interested in buying the house because it was for sale. So I asked them, I said, are those vents open in the summertime? And they said, no, they've been sealed. We've lived here 5 years. They've been sealed for the whole 5 years. When I got in the attic, I thought somebody took a hose and sprayed that attic down. That's how wet it was. I could put my screwdriver halfway through the roof rafters. They were so wet. They were like sponges. Water was almost squirting out. So I'm not saying that would be bone dry if those were open, but I don't think it would have been that wet. But there was a humongous moisture water source in that house. Not to mention what what they would create by cooking, breathing, and bathing, all going up in that attic for at least those 5 years. Who knows how long it was closed off? That was a major, major problem.
Do you consider windows ventilation if there's just two windows?
If they're open, yes.
In the attic?
Yeah.
Well, I guess, but they're not designed to keep weather out. So you're talking about like a 1920 house with windows in the attic, because maybe we'll use the attic someday, so we'll put windows up there. And then actually people get tired of going up and opening them and closing them and opening, so they either stay closed or they stay open, and then water comes in. That's just a big boondoggle, in my opinion.
Right.
They'll take the gable vents and put small windows. Like I've seen that too. So Stan, there's a question: when spray foam is used on the rafters, are baffles, proper vents installed prior to spray foam? If not, how does each rafter bay get ventilated? Won't unventilated bays affect the sheathing?
When I've seen people applying the insulation, I don't see anything. It's going right on the roof sheathing.
And I think his question is, see, that's the biggest argument. They're saying that if you spray foam everything, the attic becomes conditioned. You're not going to have that moisture, that vapor going through, and technically it's not going to cause a problem. But then again, if I guess if there's any holes or damage to it, will moisture get out through there and cause a problem? I'm going to say probably in the future, and we're going to find out. But
all right, so if that is applied properly, it is going to fill every nook and cranny. Right? It should go into every opening that can collect moisture. So the big concern is, what about moisture coming in from the outside through the roof somehow? That's the big concern right now. The reason why LJ put his boards across the front, because he couldn't fit them in to a fit where he felt they were going to seal everything. So he had his ventilation or his diffusion port behind it, coming from soffit vents going up to the ridge vent. You want to keep the roof cool or warm, I should say. It should be warm if you're creating an unvented attic, so there's no condensation, right? Because hot and cool create condensation. I don't think there's enough information on all this right now to go forward properly. I think it's going to be a case-by-case basis. The better it's installed, the better the whole system's installed, the better it's going to function. I mean, that's my opinion. I'm not an expert. I'm not even the guy putting it in. So, but it makes sense to me
that is, but I've heard, and I can't remember, I've heard of guys actually putting the vents in there and spraying over them, but I just see Jay, but I'll certainly ask LJ, Dr. Energy, and I'll get more information, get back on you, because I've heard them say that they've actually, they won't spray over insulation. They'll pull a regular fiberglass out, but I've heard them in some cases put the vents in and spray over it. But I'll get more information.
Well, we'll get more information on that.
I don't know who it Jim, just keep it Jay.
So we kind of talked about the pros and cons of sealed and unsealed attics already. Is there another slide, Jim?
Hold on. No, thank you.
That's the last one. So we got a couple minutes.
Stan, a couple things I just wanted to not throw at you, but just if you could talk about it. We see it. I see it a lot. I know you've seen a lot. Jim's probably most of the guys here, and if they haven't, I think it might be something to touch on. Rusty nails, drip marks, rust, drip marks. I mean, we talked about the mold, and what does that imply when you see that? You go up there, you see all the little drops on the, drip mark, insulation on the attic, on the plywood flooring or whatever boards are down. If you could just, you'll even see it on the insulation itself. Can you talk a little bit about that too?
Right. So you have the coldest part of a roof is the roof nail. Right. When it's in the middle of the winter, I mean, I'm sure everybody's seen frost on the nails when they go in the attic. So if you see moisture dripping off a nail, frost on a nail, see the little water stains below. If you took a plumb bob and dropped it down, it would line up with one of those water stains. You know, there's two potential issues: lack of ventilation or excessive moisture going on in the house, right? So if you, for me, I've already been in the basement. I've already seen any indication of basement dampness or seepage. I've already been outside. So I already, if there is a water problem in the basement, uncovered sump pumps that are evaporating, they're holding water and evaporating. Conditions on the outside that contribute to that dampness in the basement or crawl space. What's
Unvented,
that, Scott?
unvented bathrooms, right?
Right, bathrooms venting into the attic and not going outside.
Insulation missing in areas, you know, and
All, yeah, and an unsealed the penetrations from the house. And look at your wall outlet is an unsealed penetration where moisture can go in there and get up into the attic space as well. So there's a lot of ways for moisture to get up into that attic. Then it hits the nails that are cold and it will condense, and possibly, depending on how cold, you'll have frost. So those are all indications. Now, then you want to, I take it a step further, and I'm looking for mold, I'm looking for water stains that, you know, that's usually so little moisture in one spot that it usually doesn't get to the living space in the house. But obviously you got to call that out. I mean, people, most of the time, if it's safe, I've never been a big fan of pictures because pictures are not really big. And sometimes what you're trying to portray in a picture is not really clear. So when I have an opportunity, I want my clients to actually physically go in that attic and see what I'm talking about. And they'll nod their heads, yes, like, they know what I'm talking about, but at least they've seen it. But that to me is a big issue. You gotta correct that. You gotta stop that moisture. That's not a good thing. People are always surprised. And then I go through the whole spiel of how we create moisture. Oh, the basement looks dry. Well, we create moisture. Where's your bathroom venting? And then I'll show them the pipe. Just so and that's exactly what we spent almost an hour talking about, the unvented attic spaces need, they need to be sealed. We're trying to keep that moisture out of there. And then the other culprit is the moisture coming in from outside. And that's a culprit whether you have a vented attic or an unvented attic. But with a unvented attic, I'm getting all confused now. Vented attic, you can actually get up there and find the source of the leak and correct it, maybe from, at least pinpoint it and then go out and correct it.
Stan, real quick. Oh,
yep.
sorry. You're done.
No, we got time.
Can you touch on insulation? We've actually kind of created a problem ourselves and talk about insulation contact and non-insulation contact recess lights. And I know LEDs have changed a little bit, but you go to these houses and everybody wants recess. And when you go up in the attic, you see half the recess lights uncovered. Can you just talk a little about the insulation contact, non-insulation, and what are some indications that that this may be causing some of the problems that you've talked about?
Sure. So obviously, everybody knows that there are some light fixtures that should not be in contact with insulation, and others for overheating purposes, and others that can be in contact. But when you think about how the light fixtures are installed, we have if you take any circle, any perimeter, any rectangle, any square, and take all that leakage and turn it into a circle, it's a big hole. And air is leaking through there and moisture is coming along with it. So all those areas when you pull, and I'm not saying the insulation is going to hold that moisture back, but now we're letting it free flow into the attic. So when those light fixtures get put in, they should be sealed. And then the insulation, if it's contactable, should be pushed back, but they should be sealed. Whether it's non-contact or contactable, they all should be air sealed. And when they do energy audits, if they can get in your attic, that's what they do. They go and try and seal as much as they can. They need to cut that air loss in your house down to a certain extent so they can get their $750 from the government. So they'll be, if they can get, like I live in a Cape, they're not going to get to a lot of that. my whole second floor is finished. They're getting a little attic space at the eaves, and that's about it. They're not going to be able to seal too much in there. So that's why they say either while you're constructing the house or when you're doing renovations, you want to try and seal off as much as you can. And it makes sense. So any other questions? Anything else you want to talk about? It's 8 o'clock.
I think we're good. Thank you.
Well, I hope that was
This is great.
beneficial. I hope that shed some light on the next time you crawl in one of those attics, you have a couple different thoughts in mind when you find that conditioned space.
And I'll get back to, I think it was Jeff, right? Jeff, was that you asked that question? Okay. Thanks, Jeff.
Well, thank you, everybody. This was a great and very informative webinar. And if you have any questions, just reach out to us and we'll get back to you.
Thanks, guys. Have a good night.
Thank you.
See you.